Good morning to all present here. In this presentation, we are going to discuss about the speech processing, the first unit, particularly about the topics of phonetics and the articulatory phonetics. So, how the phonetics and the articulatory phonetics supports for the speech processing, how it is getting analyzed, what are all the machine learning algorithms that supports for the analyzing the speech processing. About those things, we are going to discuss in phonetics and articulatory phonetics. Phonetics is the scientific study of the physical sounds of the human speech, how physically they are providing the sounds and how it is scientifically calculated. Those things we are going to discuss. It focuses on how speech sounds are produced, it is getting transmitted and perceived by the opposite end. In the speech processing, phonetics helps in understanding the sound inventory of a language, which language it comes from, improving the speech recognition and synthesize these systems. It maps the acoustic signals to linguistic meaning. Three branches of phonetics are classified in that. The first one is articulatory phonetics, acoustic phonetics, and auditory phonetics. Articulatory phonetics deals with how the speech sounds are physically produced by the vocal organs from the human being by using their vocal organs, how they are producing the speeches. About that, we are going to discuss about the articulatory phonetics. Acoustic phonetics, physical properties of the speech sounds. So, what all the frequencies are mainly used for creating the sounds with clear speech? What kind of frequency or what kind of amplitude is recommended for uh, communicating the sounds? Those things we are going to discuss under the acoustic phonetics. Obviously, in the auditory phonetics, how the ear and brain perceives the speech sounds. Those things we are going to discuss. So 3 points are there. One is articulatory phonetics, how the speech sounds are produced, and as far as the acoustic phonetics is concerned, how the speeches are uh, sent as an amplitude or as a frequency, how it is getting transmitted, and how the receiver end, how the ear and brain are perceiving the sounds produced by the um, a person is getting calculated by using this phonetics, that is so articulatory phonetics. In this slide we are going to discuss about the production of the words or the sounds by the human being, how it is getting generated. Articulatory phonetics studies how speech organs such as the tongues, lips, jaw and vocal cords work together to produce the speech sounds. About that we are going to discuss. So particularly the articulatory phonetics is about the speech organs such as the tongue, lips, jaw, and vocal cords. Speech production process that is particularly simplified for the analytics. Airstream mechanism, phonetation, and articulations. Airstream mechanism in the sense it is usually from the lungs. Phonetation means vocal folds in the larynx vibrate to produce voice sounds. Example B, D stay apart for voiceless sounds. Example P or T. Articulation is the shaping of airflow by speech organs to form specific sounds. So that's sounds how it is getting generated that we are discussing in the point. Bilabial, both lips, for example P, B and M and all produced by using the both lips. So this is called as a bilabial. Labido, labiodental, it is purely from the upper lip and the lower lip and the upper teeth. F. We by pronouncing these kind of letters, you can able to understand how these speech organs are supporting for producing the sounds and how it is getting shaped. Those each for pronouncing each and every letter or a word, we use different vocal organs to produce the sound. For example, dental, tongue plus teeth, sine or theta as in the thin. So those things are an example for how the words are getting produced or how the uh, letters are getting pronounced by using the articulations. So about this we have discussed that manners of articulation, how the sound is getting made, plosive or stop, complete closure, then release. For example, P, T, K. Fricative, no, it is a narrow passage causing frictions. F, S, delta. Affricate, nasal, lateral, approximant. So these are all the manners how you can produce the particular words or the letter, how you can pronunciate those letters. So vocal classifications by using the tongue height, tongue position, lip rounding, we can classify whether it is a high or front or rounded. For example, if you want to say I, it is using high, mid, it is using E, low in the sense it is using K. By those things are produced by using the tongue height, tongue positions, front I, central E, back U. So by using the tongue itself, based on its position, how the particular characters are getting pronounced. Lip rounding, rounded by the lip. For example, U versus unrounded I. So U in the sense it is getting rounded, and unrounded means, for example, I, you can use by those things can be pronounced by using the lip rounding. So importance of speech processing and analytics, speech recognition systems, speech synthesis, forensics and speaker identifications, accent analysis. So these are all the importance in speech processing and analytics. So as we have mentioned in the previous slide about the nasal, bilabial, labidodental, dental, velar, larynx, violar, lips, etc. So by using these vocal uh, terms, we are organs, we are uh, pronouncing the words. So speech recognition systems uses the articulatory model to handle the variations in the pronunciations. As far as the speech synthesis is concerned, it uses articulatory rules for natural sounding voices. Forensics and speaker identifications can rely on the articulatory patterns. Accent analysis often studies articulatory difference. Automatic speech are used speech processing applications where it is getting used. The automatic speech recognition systems uses the phoneme models to recognize the words accurately. Similarly, allophones, variants of a phoneme that do not change the meaning. Pin and bin, spin, pin versus a spin. It improves the pronunciations modeling in text-to-speech systems. Similarly, distinctive features, properties of distinguishing phonemes. Voiced or voiceless, B, P, helps in robust speech recognitions under noisy conditions. Syllables, it units containing onset, nucleus and coda. CAT, syllable-based speech segmentations for faster recognitions. Prosodic features, stress, tone, intonations, rhythms, rising tones in questions, emotion reductions, applications, speaker profiling, natural sounding speech synthesis. So in this area, in these applications, these phonological categories are used. So this is what about the categories of the phonologicals, the example, and in which application it is getting used. So acoustic phonetics is the study of a physical property of a speech sounds as they travel through the air as sound waves. So how it is getting amplified, what kind of frequencies are used for making the signal to travel from one end to another end in the speech processing is concerned, it is clearly given. In speech processing, acoustic phonetics is crucial because speech signals are the input to recognition systems. Understanding their properties helps in noise reductions, feature extraction, and synthesis. The properties are frequency, amplitude, duration, formants, spectral characteristics. So frequency is the number of vibrations per second. It is calculated or measured by using the hertz. Amplitude, it is the loudness or energy of the signal. It is calculated by using the decibels. Durations, how long the sound lasts, seconds or milliseconds. Formants, resonant frequencies of the vocal tract. This is also calculated or measured by using the hertz. So spectral characteristics are distribution of energy over frequencies. So this is about the key acoustic properties of speech sound. The speech as a signal. Speech is an acoustic signal that is continuous, it is non-stationary and quasi-periodic. So it continues in the sense it varies smoothly over time. Non-stationary in the sense the properties change as we speak different sounds. Quasi-periodic, it is voice sounds have repeating patterns due to vocal fold vibrations. So basic signal types in speech: voiced sounds, voiceless sounds, plosive sounds. Voiced sounds in the sense like vowels A, E, I, that is a periodic signal from vocal fold vibrations. Voiceless in the sense S, F, or a periodic noise from turbulence. So plosive sounds, sudden burst after closure. Example P, T, K. So the acoustic phonetics and the signals are vocal tract. It produces the sound. It is travels as a frequency in the air, and it is calculated and it is estimated by using the spectrogram based on the frequency and the. So acoustic analysis tools in speech processing, uh, waves, spectrogram, pitch contour, format, tracking. So these are all the acoustic analysis tools which is used in the speech processing. Waveform in the sense a time domain plot of amplitude versus time. Spectrogram is nothing but frequency versus time plot showing the energy. Pitch contour shows variation of fundamental frequencies. Format tracking identifies the F1, F2, F3 for vowels. Applications in speech processing and analytics. So automatic speech recognitions, speaker identifications, emotion recognitions, speech synthesis. These are all the applications that that are concentrated by using the speech processing and analytics, which uses acoustic features for phoneme recognitions, speaker identifications, voice print analysis using spectral patterns. Emotion recognition is about the pitch, energy, and the tempo analysis. Speech synthesis generates signals with the correct acoustic properties. So this is about the basics of the speech processing and analytics. Remaining thing we will discuss in the forthcoming presentations. Thank you.